Hi and welcome to the videos for section 1.7. There's two videos for this section, and in section 1.7 we're looking at inequalities. So with inequalities, we're talking about our less than, greater than, less than or equal to, greater than or equal to. That's these problems. So first, just a note, a reminder, a caution, a red flag, a be careful. When working with inequalities, if we multiply or divide by a negative number, we must reverse the inequality, the symbol. Exclamation point. Be careful. Don't forget to do this. If you do, unless you make another dumb mistake somewhere along the line, you're not going to get it right. You have to reverse that symbol. So the first thing we're going to look at is solving linear inequalities. When we're solving linear inequalities, it's the same process as solving linear equations. So if I have, I don't know, 3x minus 4 equals 12, no, not a good number, 13, I can solve this. Move the number, divide by 3, boom, I'm done. Same idea for this, it's just now instead of the equal sign, we have an inequality symbol. So for example, let's say we want to solve 3x is less than 9x plus 4. The difference between a linear equation and a linear inequality is what? This has one answer. I solve this, actually 13 wasn't a good number anyways. Doesn't matter. So let's go with 14. There we go. All right. So if I did that, I move the 4, I get 18. Divide by 3, 6. X equals 6. That's the only answer. With these guys, the inequalities, I actually have an interval as my answer because there's a whole bunch of numbers that will potentially give me a solution to this inequality. But again, solving it, I do the same process to solve. So I'm going to subtract 9x from both sides. When I do that, 3x minus 9x is minus 6x is less than 4. To get x by itself, I have to do what? Divide by negative 6. Warning, dividing by a negative number. So that means what? Before I do anything, I'm going to switch this symbol. It's pointing to the left. Now it's pointing to the right. I switched it to make sure I didn't forget. Divide by negative 6. Negative 6 cancels, so I get x. 4 over negative 6, so minus 4/6. And if I simplify that, divide both the top and bottom by 2, I get x is greater than negative 2/3. So that means what? That means any number bigger than negative 2/3 makes this original true. And so you can check your answer. What's a number bigger than negative 2/3? Well, how about 0? So check 0. And then we choose 0 if we can because it's easy. So 3 times 0 is 0, is less than. 9 times 0 is 0, plus 4. Is 0 less than 4? Yes, it is, so I'm pretty confident that's my answer. So in interval notation, I can say x is greater than negative 2/3, or that means what? I'm going from negative 2/3 up to infinity. I know infinity always gets a parenthesis. Do I get a parenthesis or a bracket here? Well, I get what? I get a parenthesis because it's greater than 2/3, but it doesn't include it. If it said greater than or equal, then I would have to put in the bracket. Let's look at another example. So what if we have 4 is less than or equal to 3x minus 2 is less than 13. So now I have this inequality sort of in the middle. I have two inequality symbols. This is not a proportion problem. So remember in section 1.6, you had the two equal sign and there was a method to solve that. That is not this. This is an inequality. So I'm going to do, over here I did what? I subtracted 9x from both sides. I'm going to solve these the same. I want to get x by itself. The only difference is I'm going to have to do it in 3 pieces. So to get x by itself, what do I have to do? First I have to add 2. So I'm going to add 2 everywhere. And when I do that, what do I get? 4 plus 2 is 6. Less than or equal to 2's cancel, so 3x. And then less than 13 plus 2 is 15. Now to get x by itself, what do? I have to divide everything by 3. So 6 divided by 3 is 2. Less than or equal to x. Less than 15 divided by 3 is 5. So in this problem, my answer was x is everything bigger than negative 2/3. Now, x is between 2 and 5. So in interval notation, that means what? I'm going from 2 to 5. 2 is included, so it gets a bracket. 5 is not included, so it gets the parenthesis. And then lastly, another type of linear inequality is that of the absolute value inequality. I guess it's not really linear, it's its own special class. Absolute value inequality. We might have something like the following. 3x plus 2, the absolute value, is greater than or equal to 4. Now remember, absolute value is what? Absolute value is distance away from 0 on the number line. So when if we have an absolute value, we have two possibilities. We have this kind where it's greater than a number. And so when we set this up, we're going to have two equations. We're going to have 3x plus 2 is greater than or equal to 4. Exactly how it looks. But if this value, let's say this ended up negative 10. Well, absolute value of negative 10 is greater than positive 4. So to account for that, when we're solving absolute value inequalities, we want to say that this guy, 3x plus 2, could also be less than or equal to that negative 4. Because if this thing is less than negative 4, i.e. negative 10, when we take its absolute value, it's going to be bigger than the positive 4. So we get two equations. The first one just kind of as it looks without the symbol. The second one, leave what's in the absolute value symbol, change the sign, and make this guy a negative value. All right, so let's solve this one, and then I'll show you two other little things here. So we solve these separately. Subtract 2. So we get 3x is greater than or equal to positive 2. X is greater than or equal to 2/3. This one here, subtract 2. So 3x is less than or equal to negative 6. Divide by positive 3, so I don't have to change the symbol. So I get x is less than or equal to negative 2. So I have two answers here. X is greater than 2/3. X is less than negative 2. So on a number line, what does that look like? Well, this one says x is greater than or equal to 2/3, so it's a filled in circle going to infinity. And that one says -2, filled in circle going to negative infinity. So in set notation, that tells me what? It's negative infinity up to -2. Negative infinity gets parentheses, -2 gets a bracket because it's included. And then because I have this gap here, I have to say this is union. So this is including as well 2/3 with a bracket up to positive infinity with the parenthesis. So that's that type of problem. Just two little notes on absolute value. So if, instead of this here, what if it said 3x plus 2 absolute value is less than or equal to 4? So I still do the same process. Write it as it is, and then write it by switching this sign. So this would be what? Greater than or equal to -4. The example I just erased is essentially what we get. So all you're going to do, if you have this kind, so this one is absolute value greater than or equal to, so you get these two kind of problems. If its absolute value is less than or equal to, then you get 3x plus 2, and it's between the plus and minus value of this guy, whatever was on the right side of the inequality. And then you solve it the way we did that previous example. The third type is, what if I have absolute value of 3x plus 2 is greater than or equal to or less than or equal to -4. So what changed? This did, right? Whenever is absolute value going to be, well, okay, so actually I better do this in two spaces here. What if I have absolute value is greater than or equal to -4? Well, my answer is what? My answer is all real numbers, because no matter what I put in here, this is going to end up a positive number, and a positive number is always bigger than negative anything, no matter what this negative is. In the last case is 3x plus 2 absolute value is less than or equal to, or it could just be less than, same up here, or greater than -4. Well, again, this value, the absolute value, is always going to be a positive number. So when is a positive number ever going to be less than a negative value? And the answer is none, right? Empty set. We had this when we were talking about like intersections and the elements didn't overlap. The answer is none. I can never have an absolute value less than a negative value because this will always be positive. So the answer is just empty set. It doesn't exist. I can't pick a number for x that will give me a negative number because I'll be taking absolute value. All right, so that was the end of video 1. I know I told you originally there was only 2 videos for this section. I'm changing it on the fly here. There's going to be 3 because this next type of inequality, I want to separate into its own video. So if you ever have to go back and reference it, which you probably will, it'll be easy enough for you to find. So come on back and we're going to look at inequalities with a quotient.